In this video, we're going to look at a graphical approach to regression, which is referred to specifically as the three-median line. Now, to begin to work on the three-median line, you need to generate a scatter plot. And in order to have the scatter plot, you need to have two related variables, x and y, that are related in a linear fashion. So here in this graph, we've got two variables. We've got the x variable, which is the independent variable, and the y variable, which is the dependent variable. And I've just labeled those there. Now, x is the independent variable because y depends on x for its value, for the outcome. So we've got a scatter plot with, in this case, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 data points. The second step is to count the number of points, which I've just done. So we've got 10 points. We then need to draw two vertical dotted lines so that the points are evenly split. And what I mean by evenly split, if you look at this diagram here, you've got 1, 2, 3 points in this first section, 1, 2, 3, 4 points in the middle section, and 1, 2, 3 points in the final section. Now you can't split 10 into 3 evenly, of course. So it's best in that situation to have even numbers or the same number of data points on the outermost regions. So in this situation, we've got 3 on the left region and 3 in the right region, with 4 in the middle region. Now, let's say, for example, you had an odd number of points. Let's look at 11. In that situation, you would have 4 in this region here, 4 in the outer region, and then 3 in the middle region. So wherever possible, try to balance out the regions on either side of the middle region to make sure that, that the values we're getting are accurate. So again, we've got 10 points. I've drawn two dotted lines down the graph, splitting it into 3 data points on the left, 4 data points in the middle, and 3 data points on the right. Now, this third step here is probably the most confusing, and it's the part where most students get caught up. What you need to do is you need to find the median or middle number of each group of points and mark the plot with a cross. There is a be careful here though. You need to find the median of the x values and the median of the y values separately to give an x-y pair of medians. So for example, let's have a look at this point down here in the first region. This point here, it's x. We're just looking at the x values now. This is 1, this is 2, and this is 3. So in this situation, the median, the middle number of this, is 2. That's going to be our x value. Now, I'm going to rub out those numbers here because I want to now look at the y values. So in this case, this is 1. This one here is 1.5, and this one here is 2. Now in this situation, the median or middle number is again the 1.5. So I'm going to put my 1.5 in here. Now, as you can see, if I was to go on the Cartesian plane to the point 2, 1.5, 2 is here, 1.5 is there, and I put the x just there. So, hopefully that makes sense. I'll do it again with the next section. So along here, in the middle section, we've got this value here. Just looking at the x's is 4. This one here is 5. This one here is 6. And the one here underneath the cross is 5 as well. So, to find the middle number, in this case we know that it's going to be 5 because 5 falls between 4 and 6. Nice and easy. Rub those out and do it for the y variables. So this is 2, this is 3, 3, and 3. Now the middle number in this case is going to be 3 again. So therefore, the data point in this situation is going to be 5 is the x variable and 3 is the y variable. Rub out those numbers and put a cross at that point. In this last region, the x variable, that one there is 7, that one there is 7, and this one here is 8. The middle number in this case, of course, is going to be 7. Rub out those numbers, and this one here is 1, this one here is 3, this one here is 4. So the middle number in this situation is going to be 3. Rub those out, and we put our cross at the point 7, 3. So again, you need to find the median of the x values and the y values separately to give an xy pair of medians. Please don't make the mistake of doing them at the same time. You'll get confused and you'll be unable to get the correct answer. So once you've found the median of each group, put a cross at that point and you're good to go on to the next step. Now, step 4 requires you to place a straight edge so that it passes through the crosses in the outermost regions. So in this situation, you would put your ruler going through this point here and this point here. Once you've got your ruler at that point and maintaining this slope, so don't tilt your ruler to the left or right, but maintaining that slope, gently slide the edge 1/3 of the way between these 2 points and the third point. So you go 1/3 of the way between them. 1/3 of the way up. Once you're at 1/3, draw the line. Now, once you've drawn the line in, you're free to find the equation of that line. To find the equation, the y-intercept you can read off the graph, so in this case it's going to be there at the 1. To find the gradient, you simply do rise over run. You pick that point and any other point. In this case, this point here is a good one to pick because it travels exactly through the point 10, 4. And that makes it easier to work out the gradient. It won't always be the case, but it's nice and handy if it is. So we know that the rise in this case is between 1 and 4, which is 3, and the run is between 0 and 10, so there's 10. You do rise over run, 3 over 10 gives you 0.3. Now we've got the y-intercept as 1, the gradient is 0.3. We substitute the values into y equals a plus bx to give us y equals 1 plus 0.3x. Now that is the equation of the line that we found using the 3 median method. When we're choosing between linear regression models or methods, we've learnt 2 so far. We've learnt the linear regression method and the 3 median regression line. You need to keep these in mind because there's the better one to pick for different situations. When choosing between a linear regression line and a 3 median regression line, keep the following in mind. The 3 median line is less influenced by outliers. Less influenced by outliers, as it's based on the medians, the middle numbers, and not on the means, which is the average. So if there are clear outliers, you're probably best to use the 3 median line. Both the linear regression line and the 3 median line methods assume that the variables are numerical and that the relationship between them is linear. So hopefully this has made a bit of sense. When you're choosing between linear regression and 3 median, you choose the 3 median if there are clear outliers, and you should choose linear regression if there are no clear outliers. One other thing I'd like to look at in this video is the concepts of extrapolation and interpolation. Now, extra, as the word means out, extra on top of. So extrapolation is outside and interpolation is inside. Now I've just realized as I'm reading that it should be interpolation, not intrapolation. So interpolation. I'll just write that in. Thank God I'm a maths teacher and not an English teacher. Interpolation. Interpolation is inside and extrapolation is outside. So interpolation is when you are predicting, you're using the line of best fit or the linear regression line or the 3 median line, any way you've generated it, you're using that equation to predict within the range of data. So an example to clarify this, if I was to get the age and height of every Year 12 student at St. Helena, I would have 2 numerical variables, age and height. If I created a scatter plot and then found the line of best fit, or the linear regression line of that data, I could use that data to predict the age, use the age of a new student at St. Helena in Year 12 to predict their height. What I wouldn't be able to do, however, would be to predict the height of my grandmother based upon her age, because interpolation is predicting within the range of data. A new Year 12 student to St. Helena is going to fit within the age range of our data. My grandmother is going to be fitting outside that age range. Therefore, that would be extrapolation. Interpolation is predicting within the range of data. Extrapolation, as using that example again, is using a set of data to predict something that's outside the range. Now, what you could do, and my grandmother's a bit of an extreme example, but say we've got Year 12 students and we have their age and their height. What we could do is we could use that formula to predict the height of a 20-year-old student, and that may be reliable because the age difference is not so great, so it's just outside the data range. It's not a long way outside the data range. What you need to be careful of with extrapolation is that the further outside the data range that you try to predict, the less accurate your data is going to be, or the less accurate your prediction is going to be. Now, I've used this picture from the internet. I found it quite funny when I first saw it. Please do not give children cigarettes. Smoking kills. Graphically, you can use interpolation and extrapolation to make predictions. So, for example, looking at this scatter plot on the right hand side here, you could look at the line, that red line there, and you could pick a point, and I'm going to get my pen, and I'm going to pick a point just here. And what I could do is I could say, well, if I try to draw a straight line, easier said than done, across here, and a straight line down here, I could say that when the traffic volume is 10, 20, 30, 40, 240, then the carbon monoxide level is going to be about 13. 240 and 13. Now, that interpolation, because I'm predicting within the range of data, would be considered reasonably accurate. However, if I was to pick the point down here, like the arrow says, and I drop that across, that's about 7.5, and drop it down, it's about 40, so I've got 40 and 7. Extrapolation outside the data range is less accurate. It's by far less accurate, so you need to keep that in mind. You can do it from the line on a graph, or, and this is my preferred method, you can find the formula of this line and then insert any x value in order to generate the associated y value. I find that much more accurate, and in an exam you're more likely to have to find the equation of the line and then use that to predict variables as opposed to doing it by eye. And finally, here's a picture I found on the internet, and I'm not going to explain it to you. If you need it explained to you, I need to teach this subject again. Thanks very much, guys. Have a good night.